Hello students, welcome to the module number 3. We are going to discuss about heat treatment chapter. In that flame hardening concept to understand in detail. So what is mean by flame hardening? Okay, so flame hardening is just to observe this figure is a process of selective hardening method, and which is involves the heating the surface of a steel specimen with an oxyacetylene flame to alternate range. Okay, and then it is immediately um, quenching the surface with the cold water. So heating this transfer of the structure of the surface layer to austenite while quenching the changes of austenite to martensite. Okay, so only the heated surface or to certain depth it becomes hard, while the core remains soft and tough. So this depth of hardening depends on the heat supplied per unit surface area per unit time. So in the figure you can observe that there is a gas inlet will be there. That gas will be a acetylene plus oxygen gas. The combining this gas will give an acetylene flame here, and you can observe that flame at this surface on this specimen. Okay, okay, here the water will be entering through this area, and this depth of hardening depends upon the heat supplied per unit area per unit time, already we told. So thus this faster the flame is moved over a surface, the lesser the depth of hardener can be achieved. So that what we have to do, the temperature used for this method are typically in order to around 850 degrees centigrade to 900 degrees centigrade or more than that. So above this upper critical temperature, the after the hardening process and the steel specimen is going to be low temperature tempering, and process in order to improve the ductility as well as toughness. So the progressive of this flame hardening, we can achieve a proper the selective hardening method. Okay, so the only thing that you have to maintain the temperature more than 900 degrees, around 850 degrees centigrade, and here the main thing is that the carriage movement is very important. At what rate is movement is taking place, and what is the flame rate per what is the supplied per unit surface area per unit time. That is very important. The time is also we have to take care, and the specimen and the area. So these are all very important parameter while selective hardening method, so we can achieve a proper hardness of that material. So let us we can watch some of the videos related to this, so that we can understand in a better way of this process. Okay. So this is the process how we are going to take for a learners for the flat specimen. Okay, that is the real time experience, the video, how the process is going to be taken place. So for this flame hardening, we have to be maintained the proper specimen position, and at what rate that flame is going to be heated on this surface of the specimen, and also area of the specimen also very important. For certain depth it becomes hard, and so it should be maintained at uniformly. Okay, so this is one kind of flame hardening, And another one is you must know that that induction hardening. So induction hardening is like that process is going to be very simple. The steel specimen of that an inductor coil that can be um, comprise the several tons of copper tube. Okay, so that will be helpful for the acts as a primary coil, and it is transformer, and the water is going to be cooled. So then the high frequency of that copper is going to be maintained about 100 temperature to 1000 degrees centigrade per there is tubes and cycles per second. It is passed through the indicator coil. So it tests set up the magnetic field, and magnetic field is going to be produces induction currents and hysteresis current in the steel specimen. So once these currents pass over this steel specimen, it resistance offered by the steel. So throughout the result, it's going to be rapidly heating at the surface layer of the specimen. The temperature is maintained around 700 to 800 degrees centigrade, which cause the surface layer to change the austenite. So at this moment, the transformer transform the austenite to martensite. So this is the only the surface where the specimen can get hardened. So while this interior core of this remains soft, and the depth of this cutting, the hardening produced by this method is hardened, and but the frequency of that AC current also is going to be used, and this higher frequency is going to be considered for the lesser heated depth, okay, hardened depth. So the major advantage of this process is going to be the speed and ability to confirm the heating surface. Okay, so this is what we can discuss understand about the induction hardening. So all these things is just remember the points. So only you have to remember that what temperature range is going to be process, that is very important. And the rest of the thing, how the formation of get the mutton set from the various parameters like austenite and other phases. Okay, so let us will discuss some of the other topics in the next slide.